Hello, this is David, and in this video, we're going to cover a little bit of descriptive statistics, very simple things like the average and the average or mean deviation. We're going to talk a little bit about absolute numbers. We're going to think about the correlation between number sets and the slope of a line. Now, we've got two sets of data here. And I'm going to go ahead and find the average of this first one. Now I'm going to use what's called Excel functions, which you could go up to, is it data or formula, and then functions to open these. I happen to know what some of them are, so I don't have to have them all. Equals average. All right, so the average of that set is 16. And the average of this set is 16. So we have two averages, but what we don't have is an understanding of their spread or disbursement. In other words, if you had the opportunity to have a 25% chance to earn 1% on a portfolio of money, and 1%, 25% on to be 1%, 25%, 32, and 25, 32, you can see that you're either going to do really well or really bad. Now, in this other number set, you can see that the worst you could do would be 12 and the best you could do would be 20. So there's less risk, but maybe less possibility of return. So the average deviation, remember another word for average is mean, so you could call this mean. You could call this average deviation mean deviation, it wouldn't matter, but let's find the average deviation, and I'm going to use an Excel function again, equals average deviation of this number set. So it's 15, and then I'll just drag it over, and it's 3. So you can see the average deviation is much lower. Now, how the average deviation works is it looks at the difference between each of these numbers and the average of the numbers. So it would be like 16 minus 1 would be 15. 16 minus 30 would be, what would the math be, 14? And it would be a minus 14. Now we don't want those minus 14, so in a minute we'll talk about absolute numbers. But just from a risk standpoint, I like the 3 better. So by looking at both of these numbers, it tells me a lot more than just looking at the averages, the average and the average deviation. Now an absolute number is just the positive of that number. So for 0, it would be 0. The absolute of 1 would be 1. The absolute of a minus 10 would be a 10. The absolute of a 15 is a 15. And the absolute of a minus 12 would be 12. Now let's go look at correlation. I've got a number set here. This is like sale number 1, 2, 3, 4, 5. Gross living area for the comp 1, for example, might be 1,200 square feet with 2 bedrooms. Now, occasionally, I want to know, ask the question, is there a relationship between the gross living areas and the bedrooms? So I can run the correlation function. So equals correl of one set of numbers, then the other set of numbers. And I can see here that that's a very high correlation. Now remember that correlation goes from a -1 to a +1, and the -1 is 100% correlated, just negatively correlated. And the 1 is 100% correlated, and a 0 is none. So this is highly correlated. Now another thing we might have done was to take these numbers and go up to data and sort these numbers. And I'm going to sort by, let me pull this over so you can see it. Will it let me? There it comes. My number has headers, so we want to sort by gross living area and say okay. Now if I look just by the naked eye, I can see the gross living area is 1,200, 14, 16. You can see it's getting bigger. Now, what happens to the bedrooms as they get bigger? 2, 3. I can see with my naked eye that there is a high correlation. The point here is Before we sorted this, it was just data, and I know there was only 5 sales, so some of you may have been smart enough to see that. But if you'd had 200 records, you wouldn't know. But if you sort them, and you sometimes can just eyeball it, and you can see that there is a correlation. In this case, there's a big correlation. How does correlation affect us? Well, it mainly affects us when we try to do some market modeling, like regression analysis is a form of market modeling. One of the assumptions when you're trying to extract an adjustment rate out, with regression, is that these property components or predictor variables are independent of each other. So there might be some question whether these are independent with each other. And if you run some type of analysis and this heavy correlation interferes with it, so you begin to get the wrong answer, then that's collinearity. So we'll talk more about that later. Now, the good news is we're not going to use R squared in the future, but I wanted to cover it while we're right to this point. This book is about research. So what we're really doing in these early chapters is we're trying to give the reader the basic knowledge of the statistical techniques that you'll need to understand the research that we present in the later chapters. So if finding the average deviation and correlation is all we've got, I think you're in pretty good shape. But while we're right here, let's talk about R squared and R squared coefficient of determination. So, and I notice up here when I type this in, Excel took the liberty of saying that it was a registered name, but I really don't want it to be. I really just want it to be R. Correlation, the letter R stands for correlation. So I apologize, that's been up there all this time. So to find R squared, a lot of people say, well, I couldn't find R squared. Well, once you have R, then you simply square it. So we'll come down here and do that. Equals to this cell, either times itself, or I'm going to call it subhat. Sometimes I call it little hat, but 2. And that is the R squared, and that's how you would calculate it, just like that. Now, correlation, remember, is the relationship between two sets of numbers. Do they kind of behave the same? When they get smaller, does the other get smaller? When they get bigger, does the other get bigger? And R squared is really, I don't use it a lot in here. To be honest with you, R squared is kind of a misunderstood animal. And sometime I'm going to do about a 30-minute video or a 30-page article just on R squared, how we use it when we analyze, because sometimes people depend on it too much, and then in other situations too little. But you can see if it's a simple derivative of R, it's understandable, but we somehow don't understand it. But let's move on. Now let's talk about slope. Slope is the slope of a line you could think of. Now these points can be plotted. As a matter of fact, I put them down here so I can make a chart easily. I've already calculated the slope. If you look up here, equals slope, which is C5 through or C5, these numbers first, this set of numbers here first, and then this set of numbers. And so I know from a function that the slope is 50, but I'd like to see it a little bit. So let's go ahead and make a chart. Where did my chart go? Guess I never got my chart. There it is. Now let's make it a little small. Well, we'll just put it right there so you can see it good. Now these are the plots of these numbers. Now I'm going to add a trend line, and I'm going to add a linear trend line. And while I'm at it, I'm going to display the equation on the chart. And I am going to see if I can't make that line a little bit better. Maybe make it red and make it a solid line. There we go. Okay, and let me close that back out. Now, what you can see is 50 is the slope. 50 times x is the slope of the line. So there's the line there, it's 50. Now, later on, we want to understand the slope of a line because we can use this to help us in a couple of our analysis. One is an existing analysis technique that is an existing analysis technique that we sometimes call sensitivity analysis. And when the appraiser makes adjustments on the quantitative adjustment grid, they look at the adjusted sales prices, and when they start getting weird, they know their adjustment's getting off. But we can probably use this slope of the line to give us a more objective measure of that, and also something then that we can convey in our report to tell the reviewer, here's what we did and why we did it. Another thing we'll use the slope of the line for is in a new set of extraction techniques that are going to come from residuals, and we don't need to cover that now or discuss it now, but that's what we'll use, is the slope of the line. And you saw there was two ways to get it. Now the 100, these are the adjusted sales prices if these were four comparables. The 100 is how much this comp was different in gross living area from the subject. There was 100 square feet difference, and these would be absolute differences. There was 200 feet difference here, 200 feet here, and 300 feet here. So that's how we measured this slope. All right, that's the end of video 1. Thank you.